4.1. We know that
scatter
the
diagrams
discriminant
and correlation.
is b squared minus 4ac, and that has to be greater than
So
0.
first,
So we just
what
plug
have
the
to
values in,
understand
right?
is chapter
We don't know what b is,
4,
so
point
we'll
1
just
and
keep it
point
as b
2,
squared
I'm not sure
minus
about the
4
rest, are going to be about
c has to be greater
bivariate
than 0.
data
So we can just move this to the other
just the
side
relationship
to get
between
b
two
squared. It
variables.
has to be greater than 4 times
So here, one
64
explains slash
times
predicts the
25,
other. Typically,
and
that's what we're hoping for.
Once you
But
value
there's
that
cases
out
where
using a
two things are
calculator,
not related at all. So the explanatory or the independent variable, and I use the term independent here because that's typically what's used in experiments. The independent data is something you change, but it's not always going to be the independent variable. The independent variable is always going to try to be the explanatory variable, but they're not the same thing. The explanatory variable is something that's used to predict. So if I increase this explanatory variable, what happens to the response? So it's technically like the input in a function. If you change this, then hopefully the response variable will change. And the response variable is just the outcome, meaning what happens if you change an explanatory variable or just a regular other variable. So the explanatory variable always goes on the x-axis, or goes on the x-axis always. So first we have to understand what scatter diagrams are, and it's a visual tool for two quantitative variables. And we say quantitative because you can't really
variable, and that b represents a mathematical value.
measure trends without numbers
or numerical values, for which the following values
so,
b
I mean,
will
you
equation
can,
have more
but
than one
it's-
resolution.
it's gonna be
So
really
we know
hard
for
because it's
quadratics,
gonna be
we determine
more
how
statistical,
the number
in the
of
quantitative
solutions
field.
based
So
on the
it's used to
discriminant.
measure
If
the
the
relationship
discriminant is
between
greater
the
than
two
0, then it
quantitative
has
variables
two
measured on the same
real
individual.
solutions. If it's equal to 0, it has one.
So the patterns are
And
positive
if
or linear.
it's
If the
zero
slope
or
is greater than
negative,
0,
it has
negative linear.
typically
if the
two
slope is,
imaginary
less than
solutions.
0.
So we know that it has to be
Don't connect
greater than
dots,
0 because it has
adjust
to have more than
scale
one real
carefully to avoid
solution.
misleading impressions.
Or
You draw them the
two
same way you would draw it on the
solutions, and if it's
rectangular
greater than
plane.
0,
So
it has
let's
two
come here.
solutions. So that's what you should
And
memorize.
let's make
You should just
a
memorize the quadratic formula in general. But
table,
here we
and
go.
we'll assume x
So b squared
is
minus
the
4ac has to
explanatory
be greater
variable
than
because
0.
x always goes on the
And we can just remove
x-axis, much
the
like
square root and just do b
explanatory
squared
variable.
minus 4ac.
And we'll have
And that's
2,
because
4, 3,
we can just factor that in
7,
at the end.
so
So we don't know what
10.
b is, obviously. That's what we're trying to find. So b squared
this seems
minus
perfectly linear,
4.
so let me actually
is
change that to make
negative
it not linear.
1.
Simply just so
Oh,
it can
sorry.
add a little bit of nuance.
B is
Um,
64.
So this is x,
And
C
c
y,
is
explanatory
25.
variable, and the
And that
response
has to be greater
variable,
than
which
0.
is
So all we
change
did was
the,
plug the two
explanatory
values
variable.
into here.
And we'll draw points
So
on our
b
line
squared has
to
to
indicate
then we can just move this to the other side.
areas.
So b squared has to be greater than
And we'll do this by 2
um,
to 2.
positive
So we have enough
4
space.
times 4 times
And we go up to
25.
12. Perfect.
And when we
So
evaluate
first
that
we
out
go
on
to
our
2 and plot
calculator,
4.
we get 6400.
Much like a Cartesian
B
coordinate plane,
squared
much like you would do in
has to be
math,
greater
go to
than
the x
6400.
and then the y value.
And we simply square root
Or
both
you can go to the y value.
Now,
then
when you
the x
square
value. It
root
doesn't really matter.
a
You go to 3, go to 7, which is in
when
the
you
middle
square
of
root
6
in
and 8.
order to find a
4 and
squared
12.
variable, you typically do
So
plus or
a mistake a
minus.
lot of people like
But
to
in
do
this
is they like
case,
to connect the
we're
lines.
just going to do plus.
And
because if
although
we-
this can give you a good
or it doesn't
indicator
really
on
matter.
whether
And here we'll see that
the relationship
so
is linear
b has to be greater than
or
square root of 64,000,
exponential or
which is
another
simply just
form.
plus or minus
What if you
8.
have 2 dots in the same area?
So
Or 2 dots
it can be plus or minus 80.
on the same x
and
or explanatory
yeah,
variable.
That's the answer.
Then how would you connect
Wait,
it?
how's that a?
And the simple answer is you
Okay.
don't connect it. So when we're making a positive relationship,
shit.
a positive relationship is going to be if the slope is positive, meaning that as x increases, y increases. So yeah, or you can write as m is greater than 0, which is the same thing as being positive. As x increases, y increases. M is less than 0. That means as x increases, y decreases.
And this one's pretty
Um,
simple.
and
but
x
a little
as
bit more
x goes
complex and
negative,
easier. Once I will give this
y becomes
difficulty
increasingly
rating
positive.
about a 3 out of
So it'll
5.
be kind
So
of
the
like a
given
downward
equation
trend.
b is a constant. When it's a constant, it just means that the variable
As x
b
decreases, then
is
the
not
magnitude
a
of y's
variable. It
negativity
represents
goes
a
down
mathematical
because
constant
there's
or a
less
numerical
input for the
constant.
negative
Sorry if that's
function.
under
And
me.
if m is
So
equal to
basically
0,
that means b doesn't
then,
change like x. or
Typically,
another
there's no
variable that you would
relationship at all
typically
with
see
linear
within
line.
a function.
And we
So
all know that
for which of the following
mathematics
values of b will the
algebra
equation
1,
have more than
so
one real solution?
that's all
So
you
for
need to
quadratics,
understand
we determine the
for
number of real
scatter diagrams
solutions
for the most
by
part, but we'll get to a
determining
little
what the
bit
discriminant is.
later.
And
So this is
that
typically how it
means
looks.
that it can have
And here it looks like there's no
options.
relationship,
If it's
right?
greater than 0, it has two real solutions.
I guess
If
you
it's
can
equal
draw
to
it like
0,
this way,
one
this way, and
solution.
this
If
way,
it's
and
less
it
than
would
0,
still
typically has two imaginary solutions.
be relatively
But
close
here
to
we're
all the
given
dots, no matter which
that
way you put it.
it has to be
but this is like a case where it's really
more
hard
than
to
one real
determine
solution, and that
what the
means
line is,
two
and
real
that's what
solutions,
we'll
which
get
means
to
that it
find
has to be
squares
greater than
regression
0.
in the next lesson.
And basically, b squared
That's
minus 4ac
now
has
here
to be
we get
greater
to the
than
correlation
0.
coefficient, and it's the measure of
And
whether
we
the
just
two
plug in the
variables have
values
here
that
to
we
show a
know.
relationship.
And
So the
we're
range is
trying
from
to
-1
find
to
b,
1.
so
It
that
can't
still
be
remains b
-1.5.
squared,
It
because
has
we
to
don't
be
know what
between
b
these.
is.
And
we
the
do know
reason
what
is
A and
actually
C
pretty
is, which is
ingenious, which I'll show you later.
64.
So if r equals 1, it's perfectly
25.
linear. If it is -1,
Has to be
it's
greater than 0.
decreasing linear.
Now
If it
this is
close
just the
to
same
plus or
thing with the
minus
values
1,
plugged in.
it's stronger
yada, yada.
linearly.
We
If r
just
equals
move this
0,
to the
there's no
other
relationship.
side
R is
by
unitless, and it's
adding
not
it,
resistant to outliers.
and
Meaning
that
that if
would
there's a
be
huge
squared
outlier right
is greater
here,
than
r is still
4,
going to account for
25. Pretty simple
that
so
not
far.
being in that
Now
relationship.
b squared,
Or that being just an outlier.
now we're gonna
that
square root
is hard
both
to account for
sides,
in the relationship.
and
So note
this
the
just
slope and the
evaluates
correlation
out
coefficient
to
must share the same sign.
b
If one
is
is negative,
greater
the other
than
must be. And we'll explain that right here.
425. When you square root, to
So
find
if r
a
is
variable,
positive, then m is also
you have to do
positive.
plus or minus.
And the reason that it
And
is pretty
in
ingenious,
this
which
case,
I'll show
it
you.
won't really matter.
Obviously, I was talking about that
So
before.
b has to be greater than.
But r, all it indicates is basically whether
square
it's
root of
decreasing
6400,
linear
which is
or
just
increasing
going to
linear.
be,
It's the same
80.
thing.
So
But
b
really
has
what
to
we're
be
focused
greater
on is how
than
close
plus or
r
minus
is to 1 or -1. We don't care
And
about
it
the
doesn't
sign,
really
because all the
matter,
sign
it's just whatever
indicates
is greater than
is
plus or minus.
how the line is
So now the
moving.
question
It's moving
states,
from
which of the following
left to
values
right, down to
so
up,
we know that
or
b can be anywhere.
left to right, up to down.
Or plus or minus 80.
So the closer it is to 1 or
following
-1,
values
it
will the
has a
equation
perfect
have more
relation.
than
If
one
r
real
equals 1, it's
solution?
perfectly linear,
So
which is something like
b has to be greater
y
than
equals
80,
x.
or
It's
it has to
perfectly
be
linear, it's
less than
perfectly
negative
straight,
80.
and it
And
hits
the
all
reason is
points,
because when it's
within
negative
that
81,
data
and you
set.
square that, it becomes
Um,
positive, making that
so yeah,
numerical value
and
higher.
typically,
However,
your
if you were
textbook will
to
tell
add
you
to negative
what
80
is
and get negative
considered linear,
79,
or what is
negative
considered
70,
a,
and you square that, it's going to be
linear
less
line.
than,
And a good rule of thumb is if r is
then
greater
the
than
more
like
negative number,
0.7,
pretty much.
it does
So
appear to
when
show a
you're
linear
dealing with,
relationship, because the r is just a measure
a
of the strength of the
quadratic
linear
or squared
relationship.
variable,
So
you
check
get
your
a
textbook
higher
to see
value
what
and a
it
higher, more
considers linear,
positive
if it's
value
greater than
with a more
0.7
negative number.
or whatever. But I would say
It's
around
crazy.
0.7
Basic.
is what I like to consider.
So we know that it has to be
perfectly linear.
greater
Or
than
not
80
perfectly
or
linear,
less than
but
negative
appearing
80.
to show
So as you can
linear
see here, there's
relationship.
nothing that is greater than
And this
80.
looks pretty complicated, but it's
And
pretty easy if you watch my previous videos.
there is
just
something
use
that
the
is
Z
less
scores.
than negative 80,
So
and as you see
we
here,
first find,
negative
and this is
99.
for pop
And
or for samples,
yeah,
because we have the n minus 1
that's it.
Bessel's correction
I'll
term.
see you in the next one.
So yeah, if we're just using pure logic, it would just be all the x scores times the z scores added together over n minus 1 for the frequencies. And note that n here is the amount of coordinates or x comma y groups. It's not the amount of x and y, so that's important to note. Here's a simpler formulation: 1 minus or 1 over all the data groups minus 1 times the sum of all z scores and y scores multiplied. And here's the same thing, except you don't subtract by 1 here because you have everything to use in the population. A positive association, both variables increase or decrease together. Negative association, as one variable increases or decreases, the other variable decreases or increases. So negative association is if r is negative, and positive association is if r is positive. So here's just a general rule of thumb. And sorry, it's a little bit cut off, but if most points are in quadrant 1 and quadrant 3, you can see that it is starting to go up as x is increasing. If most points are in Q2 and Q4, you get a negative correlation. If the points are evenly scattered, the correlation is near 0. So it is slightly misleading because if it's through all quadrants, it is 0. But it can also be in some quadrants, like right here, or this area right here, this area right here, but it can still somewhat show a linear relationship. So if it is all scattered evenly with basically with no indication of linear regression, then it would be an R close to 0, because an R is a measure of how much the data can fit a linear relationship. So the formula simplifies R equals 1 over frequency. And not frequency, it would be data points, or frequency at data points, which is what I mean, and this is a little bit more complicated, so I'm not going to show you that because we've already gone to that before. This is the population correlation coefficient. Note that these are z-scores. I believe that's the foo Greek letter. So understand that correlation coefficient does not mean that one variable causes the other. They can both be response variables. If the data uses in a study is observational, we cannot conclude the two correlated variables have a causal relationship. That's a lot of words, but simply put, it means that even if there's a linear relationship between the two, it doesn't necessarily mean that one causes the other. They could just both be related. So, for example, let's look at percent of people who use air conditioners, and percent of people who get or just violent crime. So let's say as people who use air conditioners increases, violent crime increases. So the obvious answer, or what seems apparent, would be AC causes violent crime. But we all know that isn't the case. I mean, we don't know for sure, but that doesn't mean, if we stop using AC, violent crime will go down. In fact, it could be the violent crime could be caused by what's called the lurking variable, which is something that's not associated here. And let's say the lurking variable is heat. As the day is hotter and people use more air conditioner, then violent crime goes up. So these two can actually both be explanatory variables, or response variables, and this could be the explanatory variable. The day being hotter explains why more people use AC and more violent crime goes up. Taking away AC doesn't mean violent crime is going to go down, because it's still going to be a hot day. So it's important to note correlation coefficient, or doesn't mean that one variable causes the other. It just means that two variables show a linear relationship.